day to all of you there in Europe. I'm going to start by saying that I'm 75 years old. I've been at this for 45 years. Lots of times at the end of the university year and students have trained, we have this thing that's like speed dating, where you sit at a table and the students sit down in front of you. They got 5 minutes, then the buzzer goes and they move to the next lecturer or professor or whomever it is, and they ask the questions. The number one question that everybody asks me when they sit down in front of me at the end of the year is, what do I do? I don't know where to go. I don't know what to say. I don't know how to get a job, basically. And this is a little bit off humanitarian engineering, but I got to tell you this. It's worked for me. I mean, I know people all around the world. I've worked in over 100 countries. I've worked in 20 countries in Africa. I developed building code. I developed training programs. I built probably 30,000 homes in Africa. I have projects where I've got 1,500 to 3,000 people working on a site at one time with 4 trainers, me and 4 trainers. So that didn't happen overnight, and that took a long time and a lot to work out. But how did I get there? That's the question. How do you get there? And the point is, you don't need to be old to get there. I remember once sitting on a plane in first class, and some people were getting on the plane, and this woman looked at me and said to her husband, who was an engineer, "Boy, I hope we get to sit up here sometime." And I said to her, "Yes, you will when you put your time in, but really you don't need to put your time in." So how do you get known, and how do you get out there if you're interested in this type of work, and that is working in developing countries? See if I can grab one. Yes, I have a business card, which you can see. It has my picture on it. What I do is I go to conferences, and I realize that as a student, you don't have money for conferences, but conferences are critical. That's where you meet all the other experts in the world. Maybe let's don't use the word experts. All of us continue learning. Even though I've been doing this for 45 years, I'm still learning. So you go and you meet these people. So you just sort of suss people out. You know, you have morning breaks, you have lunch and whatever, and you just walk up to them and you chat to them, tell them who you are or whatever, just start chatting to them. And you'll find that in a group of people, there's someone you like. And before you leave that, and you may only talk to them 5 minutes, you give them a business card, and your card has your picture on it. Now, hopefully, this person or persons will reciprocate and give you a card as well. Now, you will notice their card has no picture on it. So you may want to write a note on the back, you know, really friendly person from the Czech Republic, so I need to get in touch with them, or this person does whatever. And when you get home, the first thing you do is you send them an email. And in your signature block at the bottom of your email is your picture. Now, what will happen is that they'll open your email, and it's just very short, saying, "Hi, had a great time in Prague," or wherever the conference was. "It was nice talking to you. I hope to see you in Prague again," or "I hope to see you at the next conference," or "If I can ever be of assistance, let me know." And they'll look down at the signature block and see your picture. They will then remember your face, and when they go to look at your card, there's your face again. And at Christmas time, I send out a Christmas newsletter saying what I've done that previous year. And of course, on my Christmas newsletter, which I keep to 2 pages, has my picture on it. And it's just really great reinforcement. And you'll be surprised how you will make friends, and you'll start to network and move your way in, and it will help you to become successful. Of course, you got to know your stuff. I'm just saying that's a little tip for you. The other thing that I've learned over the years is that for probably 40 years, every time you meet someone, they say to you, what do you do? Or, what do you do for a living? Or how do you make money? Or what's your professional background or whatever? And people have been asking me that question for years and years. And so I studied architectural engineering. I did my PhD there. I studied construction management. I studied design. So I had a lot of different degrees, and I never really knew quite where I fit in the big gamut of who am I and what am I doing. It wasn't until just about 5 years ago that I sort of said, for some reason, wait a minute, I'm doing humanitarian work. And so I'm doing humanitarian engineering work. Because what you find is that architects, as you would know, just sort of do design and they pretty much stick in that basket. Whereas an engineer really is responsible for everything. And the engineers can really do design. And lots of times, that's what we do. We design something, then we engineer it, and then we project manage it, and then we hand the keys over. We do the whole thing so much of the time. And so I realized doing that all around the world in all of these developing countries and lower socioeconomic countries, that's exactly what I was doing. I was doing humanitarian engineering work. And so today, when someone asks me, it's easy for me to say, I'm a humanitarian engineer, and just go at that and let them sort that out. Now, if they're interested, they'll ask me what I do. So I'm sort of skipping around here a little bit, but and I made myself some notes, but I want to talk a little bit about maybe some of the work that I've done and some of the projects. And I must tell you that we don't always get it right. And I see a lot of this in relationship to aid work. So whether it be United Nations or aid from various countries. USAID, I've seen a lot in Africa. I've seen a lot of failures. I've seen a lot of do-gooders. Yeah, maybe that's a term I should sort of look at with you. There are plenty of churches and organizations that want to fly off to Africa and build a school, build a church, build a house, build something, maybe even hand out some Bibles, convert these people. In the back of their mind, these poor savages don't know what they're doing or can't help themselves. So along comes this white fella, and I'm going to do something for you. I'm going to build you a school, and look at me. I'm going to give you some books, and there you go. That's a do-gooder. When you go home, when they go home, we don't know if we've stepped on them, if we've been changed their society. And as you know, some of these societies have been going on for thousands of years. And it's easy for us as a humanitarian engineer to destroy a culture very easily. I'll give you an example of this, at least one. I was working in Zimbabwe, and as you know, in Zimbabwe, there was a 27-year war. Everything was destroyed. There was no infrastructure. And Krupa Price Library, which is a international accounting firm, maybe some of you might know them, they're international, huge firm. They came to us and said, we want to reintroduce macadamia trees and nut production in a particular place in Zimbabwe, a place called Chichi. And they wanted to establish 500 1-hectare little farmlets and put 500 families there. And so I think the project was about 20 million euro or something. I don't quite remember. Now, it takes about 5 to 10 years for a macadamia nut tree to actually start producing the nuts. But because of the wars and because of the elephant migration before the wars or during the early parts of the wars, the elephants would migrate through, eat these macadamia nuts, poo out the other end, the bit of macadamia nut, and up would pop a macadamia tree, and macadamia trees were everywhere. But then as the elephants started getting killed and all that environmental system changed, the macadamia nut stopped, and so that's why we were reintroducing this. As part of that, next door to where I was working, you want to say it next door, was about 50 k's down the road. There was this American woman, PhD in engineering, civil engineering, I think it was, and a PhD in environmental sciences. So she had two. And I was talking to her one day, and she told me, I'm a black woman. These poor savages have no idea what they're doing. I'm going to fix their problems. And so that was her attitude, a do-gooder. You see, back to being a do-gooder. And she went to this particular village, and these women had been walking up and down this footpath from their village to this river every day forever, for hundreds of years. And it was a tradition for all the women to go to the river with the children, and they'd bathe and they'd collect water. On the way home, they'd collect firewood. They'd come back. And the men, as a typical thing in so many places in Africa and so many places in the world, men do nothing. They just sit around. They still think they're warriors. And so they do nothing. They just bash women, beat the hell out of women, drink, smoke dope, do whatever. And so what happened was this black woman from America, this American black woman, said to me, I'm going to put a pipeline, a water line from the river back to the village with a solar pump so that these women don't have to go to the river every day. And I mean, there was nothing I could say or do. That's what she did. Within 1 month, you see, these women then didn't have to go to the river every day. Now these men were back there drinking out of their beer pots and smoking dope and doing whatever. They started bashing the women. The children started being abused. And she destroyed that whole cultural system with her, what she classified as humanitarian engineering and her do-gooder status. So we have to be extremely careful. And I guess the point I'm making here is that the first thing we need to do, whether we go into a village in Zimbabwe or into a small town in Guatemala or whatever it might be, any place in the world and those places, we need to find out sort of who's in charge. And sometimes, as you can appreciate, there is a group of people here, maybe one mob here with a leader, and a different mob over here with a different leader. And sometimes these mobs don't see eye to eye. And that is extremely difficult to negotiate around. And within Australia, when I go to these particular type of communities, sometimes there are 5 or 6 different groups with different leaders, and they fight each other. So for me to be successful in delivering a project in a place like that, as you can appreciate, is extremely difficult. So our job is, an aid organization, or maybe the Czech government says, we'd like for you to go and deliver a school in Kenya. And you go, okay, and they say, right, we want you to go to this particular village, and we want you to put a school there. And so you go there and you have this money that they've given you, this government money, this aid money, and you go there to deliver a school. Now, before you start thinking about what the school looks like or building a school or who's going to do the building or all that, you need to negotiate with the leaders of that community. They need to be 100% aware of why you're there and what you're going to do and what you're going to deliver. And also, they need to understand that if money allows, that you will be back. You're just not this white person blowing in here to deliver this thing and then out, and you feel good about yourself, and you go back to the Czech Republic and you start bragging about this school you built in Kenya. There's so much more to it. So anyway, once you've done all those negotiations, you'll find that the people get to know you. Now, look, that's not going to be done in one visit. That might take 2 visits, that might take 5, that might take several. For me, Africa was a little bit easier. I hit it very easy because with luck, it was strictly luck. So I attended a conference, I had my business cards, I was sent there by the Australian government to deliver housing. Nelson Mandela, the first president of the Republic, decided that they had a white paper and they needed 1 million homes. And they didn't need them yesterday, they needed them now, right now. And so my job was to go there and to deliver earth technology, to write the building code, to develop the trainee manuals, which I will tell you took me 18 months. It is not easy. Now in South Africa, we only dealing with 10 languages. So, but that worked out because that was very difficult, because in developing those trainee manuals, what I discovered is that Zulu language has very limited vocabulary, less than 20,000 words. So when I started writing a manual for the trainees, they didn't have a word for plastic. So I had to invent a word in plastic using plastic. So I might have said plastic or something. And then I had to put it in print, and they don't read. They couldn't read. So what we had to do is we had to run a training program. They look at the pictures so you can appreciate the graphics were critical. Very few words. No picture had more than 10 words. And I had to make up a word in Zulu so that someone who could read Zulu could read that word, but they had to be able to understand what it was. And so it took me 3 or 4 or 5 training sessions, each one of them lasting 3 months at a time, to develop a word. And so that wasn't the only word. They didn't have a word for glass. And there were words that we had to develop, run these training programs until we got it right. So there was the training manuals, and then there was the train the trainer manuals we had to develop. And then we had to develop the builder manual, because the builder didn't know how to put earth blocks or rammed earth or mud bricks or compressed blocks or whatever it was together. They had no idea what it was. They knew about some soil, but as you would know, as engineers, that, you know, soils aren't soils, and only particular type of soils. And so we have to know all about soil testing, and how do we get that across to them and teach them about that, even though they've been building with earth for thousands of years. And so after the builder's manual, then finally we had to write a professional manual for the architects, the engineers, construction managers, and those type of things. Then we had to write the building code, and then we had to write a thing called an AGMAR certificate. So that, like in a place in South Africa, which is owned by the AGMAR certificate is owned by the scientific research facility in South Africa. And so what we did is, if you as a builder or you as an architect, engineer, or whatever, wanted to build a home with earth, you had to go and get the AGMAR certificate, so you had to pay for it. Then they gave you the manuals that I wrote, And then you had to follow those manuals step by step to build this thing before you could get it certified. So you can see it was a hell of a responsibility on me, and it would be a hell of a responsibility for all of you as well. I mean, the pressures on you are enormous because you can appreciate the last thing that we want in engineering is a structural failure. So it's very difficult. So as we develop all these things to go with these structures and this training and working with the community, now we need to engage with all these people that we're going to train. And I spent my first 20 months in South Africa working. I was there to write all these manuals and to develop the building code and get that all right. And as part of that, I was to deliver 4 homes. That's all, just 4 homes as training homes. And then I was to leave and move on to my next project. So at the end of the 20 months, I said to my boss in Australia, he said, how'd we go? I said, well, we succeeded with what we were supposed to deliver. However, we failed. And he said, what do you mean we failed? And I said, well, really, we went about this wrong. We came here, the developing of the manuals and all that, that's fantastic. That worked. But we now need to run a training program to implement using all the manuals. And so he said, well, what do we need to do? And I said, we need to develop a training center. And he said, well, what's that going to cost? And I said, I can do that for 2 million Australian dollars. So he just got a checkbook out of the drawer, wrote me a check, and away we went for another 3 years. Now, what happened was because of me sort of going around meeting people, giving them business cards, following up with emails, talking to people, networking the hell out of South Africa. And at the time, you know, apartheid had finished and there was a new South Africa. And all the Black people there wanted the home now. And what they wanted the home that was just like the white fellas down the road, which was concrete block. So you can appreciate, for me, trying to sell them on earth housing was virtually impossible. So I had to use my engineering skills and my knowledge of soils to overcome concrete. And there are plenty of people there at CTU that know a lot about soils and can tell you that we can get the density of earth to 2,300 kgs per cubic, not a problem. So we're doing equivalent to concrete. It's not a problem. The right type of soils put together in the correct method using very small amounts of stabilizer. Some soils, for example, less than 5% will make 1,800 to 2,000 kgs. The density on blocks very easily. Anyway, I'm not here to talk about soils. So we put this all together, and what happened was I said to a tribal chief, gather all your people together. And so we were standing up on the back of a truck. We had several thousand villagers at this place. I got 2 20-liter buckets, and I had made some earth blocks. I put an earth block in one of the 20-liter buckets, a concrete block in the other one. We filled them both with water. And I said to the tribal chief, keep those blocks topped up for 1 month, and I will return in 1 month. And I told the people I'll be back in 1 month, and I'll show you what happens. Now, they had all obviously lived in these mud thatched houses that every year they had to get out there and re-render them and put more mud on them because it washed away. So I was proving to them that blocks put together properly will not wash away. I went back there in 1 month. We pulled the concrete block out. We broke it in half. We passed it around the masses. And as you know, concrete block, it was totally saturated top to bottom, all through the middle. We pulled the earth block out. We broke it in half and it was completely dry inside. The whole 1,000 people, several thousand people, the noise was so loud you couldn't hear it. We had the very next day 500 people get in the queue to sign up to build an earth home. So this humanitarian engineering thing is very deep, very complex. And I'm just sort of realizing that myself, actually, because I'm developing a new humanitarian engineering course at the University of Wollongong, where I am. And tomorrow I'm meeting with the head of school to discuss that. Obviously, with the virus, that didn't work for us this year, but next year we'll be underway. Anyway, I'm talking a lot and I'm not sort of showing you any pictures, but I think the other thing I wanted to tell you is that in this particular picture that you're looking at, there's me with two elders from a particular community. And you notice I have a little model. It's a very simple model. People do not understand drawings on a piece of paper. No matter how many times you go through that drawing and you show them this is the floor plan, you get from this room to that room via here, it just doesn't work. You have to have a live physical model that you can take the roof off, that you can say go from this room to that room via this door, which they can see. And they will tell you straight away if there is a problem. One of the things that you will not know, and that I don't know, and that is that we, no matter how much research we have, we don't understand the cultural significance of a particular community, whether it in the Democratic Republic of the Congo, or whether it be in a remote community here in Australia, or somewhere in Belize, or Guatemala, or Mexico, or wherever it might be. We don't know. And so hopefully by us talking to these elders, they will tell us those things. Now, a lot of this information is culturally sensitive, and they will not tell you. And again, let me share a short one with you. Here in Australia, an Indigenous man marries an Indigenous woman, and that Indigenous woman, hopefully, most of the time, has a mother alive. The husband is never, ever allowed to speak to the mother-in-law, nor is he allowed to look in the eyes of a mother-in-law. Now, they live, whole family, in a house. So we've got a typical, let's say a 3-bedroom home, sort of rectangle shape. It's got 3 bedrooms, it's got a little bit of a lounge, a kitchen, typical thing that you would have in Prague, what we have here in Australia, whatever. And in there could be anywhere between 10 and 25 people. So obviously overcrowding is a major issue. And you can appreciate the amount of problems that 25 people in 110 square meters creates. Turning lights on and off, the switches go, light bulbs blow out. They know nothing about maintenance. So there's all those problems. But on top of all that, if you're married to your wife, you can't look at your mother-in-law or talk to your mother-in-law. So if she's walking and you want to go to the toilet, well, you can't go to the toilet. Or if she's sitting on the lounge or sitting in the kitchen, you can't go in the kitchen. So that's okay, I know that. But I have to work the design around that particular type situation. And what you'll find is that in all cultures, there are these idiosyncrasies that we need to understand and to be able to design and build around. And it is extremely complex and very difficult. If you just went there and built this house, said, there you go, here's the keys, and walk away, you can appreciate that now all of a sudden the husband's angry, he starts punching walls, and he starts beating the hell out of his wife. Maybe he starts abusing his children, etc., etc. And you have created, you have, I have, we have created as the humanitarian engineer all of these problems. That is our fault. So we have to sort these things. Now, do we get it right? As I said in the beginning, no, we don't always get it right, and we make mistakes. But gee, we need to learn from those mistakes. And I think for me, as a 75-year-old man, it is very sad for me to understand that young people don't want my knowledge. I'm standing here saying, I've been doing this for 45 years. I will give you everything. I will tell you everything I know. You can take it or throw it away, but hopefully it'll help you. And they say, no, we don't want it. We want to do our own thing because we know how to do things. You're an old man. You don't understand. So I walk away from it. So it's very frustrating for me. Moving on, I'm getting bogged down here a little bit, but I think, I've tried to just sort of touch on these things of how you make things work, how you get into humanitarian engineering. I think as you go on, like, for myself, you just never know. Once you get a job, it's like the next consultancy is just around the corner. Most people prefer just to go down to the firm, clock in there every day, get the paycheck. They can buy their house and car and forget about it. So humanitarian engineering work is extremely difficult. You never know when your next paycheck's coming. You don't know what your next job is. Lots of times, many times, you're out there putting your life on the line. I mean, I've been stabbed, shot, I've been beaten, I've been robbed, I've been all those things. And most people would give it up. But that's just the majority, just a few people. Most people are really good. They want the help, they appreciate the help. And when you really work with them, they will really, really reward you. And the thing about it is that we learn all these things in engineering about structures and how structures go together and how we tie structures together and all that. That's fantastic. But when you're out there in the field and humanitarian thing, you got way outside the box. I was on a project in Swaziland and the people needed a school. Now, the average wage, if you have it, of people there painting and carving and sewing things would have been somewhere between $2 and $5 US a week if they were lucky. And so there's no money. A bag of cement in Swaziland would cost $15 US. So you can appreciate 3 to 9 weeks worth of work to buy one bag of cement. What are you going to do with one bag of cement? I mean, it's just not possible. So for me, I went down to the tip. The tip's where you go. And I seen all these 2-liter plastic bottles. So I said, okay, well, we're going to build this school with plastic bottles. So we just got all the kids, all the women, all the men. We put soil into the bottles. We filled them up with water, put the cap back on them, and we started stacking them. And that became that. We found an old car down there. We took the windscreens, the side windows, became windows. Anyway, you got the picture. We built it for nothing. I think we built this school for a total. It cost us about $500. We built this thing. It housed 30 children from memory. So those are the things. I remember once being at a tip and I seen someone had tipped all of these nylon stockings. So I took all of those, we filled them up with soil. They held all the soil together. We put them out in the sun, wet them, we put them in the sun, dried them, stacked them as blocks. Once I found milk cartons, 1 liter milk cartons, filled those up. So you get the picture. So the tip, the rubbish tip or whatever you call it, that's where I get a lot of material for this work in various places around the world. And obviously we where we use natural materials as well. So anyway, look, so there I am in that picture, with these Indigenous fellows. We're looking at the model. We left the model on site so they could look at it while we went along. And just show you a few things. This is a place in Australia, you can check it out. It's a place called the Elizabeth River. It dumps into the Pacific Ocean, if you have it, right at the Great Barrier Reef. There's probably about a little over 100,000 hectares here. this bit of particular country here. No white fella has ever been in there except for me. We flew in there to a helicopter, and the traditional owner wanted to build a resort, a tourist eco resort. So we did a bit of design work. We put it on this little island right out there in the black where all the, in the back of the top of the picture where all the blue is. That's the Pacific Ocean, and the Great Barrier Reef is right there. There's fishing and there's crabs and there's lobsters, and there's also a lot of saltwater crocodiles, some of them 6-8 meters long, so huge thing. So they asked me to do that type of work. This is an old store out in the middle of a place in the Northern Territory here in Australia, and they wanted to redo the store. And so my model said, well, this is what the new store will look like. I'll just splice through these. You can sort of see some of the work we had. This is the front veranda. Now, the other thing that you encounter in Australia and other places in the world is asbestos. I mean, just because we banned asbestos and just because you banned asbestos, asbestos is live and thriving in other parts of the world. I remember when I first went to South Africa, a man came to me because I was on an aid project from the Australian government. He came to me and he said, I would like to supply you roofing material. And I said, oh yeah, okay. And he said, would you come out to my factory and have a look? I'd like to show you what we manufacture. So I said, sure. So I go out to his factory, and there's me and him and a couple other people, and we go into this room. And so these guys go into this room, and these suits, coverall type things off the wall, and they start putting them on. And then I see that there are helmets and breathing apparatuses. And they say to me, well, you know, start getting suited up. And I said, what's that? And they said, well, you know, we manufacture our product with asbestos. And I said, well, we don't buy asbestos products. We haven't for years. No, we can't do that. And I looked, there was a window in the door, and I looked through the window in the door, and there out there were all of these Zulu men making this asbestos product, roofing, and they weren't black, they were white. They were breathing this, and as we know, they won't be living long. They'll be dying. And so obviously I stormed out of there and never went back there. But the product was very cheap, and I could have not went there. And they said, oh yeah, look cheap. Yeah, I'll buy that, and not ask the question about asbestos. So I'm telling you, you've got to always think about asbestos. The reason I'm saying that right here in this picture, these walls are all asbestos. And the flooring is asbestos sheeting. And so you're sent out to do this project, you're given $1 million to renovate existing building and to build an extension on it, which isn't much money, $1 million. And then all of a sudden you see there's asbestos. So you say to the builder who's contracted to build this, what are you doing about the asbestos? He said, oh, don't worry about it. Now he's out in the middle of nowhere in Australia, out of sight, out of mind. I just get some of these local black fellows here, these indigenous mob, and they'll just come over here and I'll make them take it out, and they'll take it down the tip, and it's all over. So I had to stop the project, insist that the builder get a crew in, a special crew, to remove the asbestos, which finally was done. Obviously, I had to take him to court and sue him, but he did do that. So asbestos is a major problem. Inside the building, this is a typical type. Remember, this is the general store in this community of about 500 people. And you can see all the electrical wiring. You know, that picture tells it where we are. And so the whole thing needed to be gutted, and then we got asbestos, and so it's a whole complete new rewire if you have it. And the other thing that we have here in Australia is that we have these ants that were brought in via containers were called Singapore ants. And Singapore ants love to eat conduit. So you've got electrical wires in the ground somewhere, and they're inside conduit, and the Singapore ants have eaten all the conduit, stripped all the plastic off the electrical wiring, and you're there for a job for X dollars, and then you discover you got to replace all the new mains and so forth and so on. So there are all of these hidden things. Again, this is all part of humanitarian work. No one ever told me about that. Who trains me to get through that? No one. These are things you need to learn. And these are the kind of things I was talking about that I'm willing to share and train people to do, but no one seems to be interested. Okay. And there you can see there's sort of halls and there's all sorts of things. Again, another one sort of thing there. But you've seen a picture of the front veranda where I talked about the asbestos. This is our finished product. This is the front. And you can see these are all some of the people in the community. This is opening day. All the tribal leaders are there, the speeches and so forth and so on. So very successful project in the end. I had to sue the builder twice. And the other thing you find is that in humanitarian work also, just because you're in the middle of nowhere doesn't mean that you forget building code. And in this particular site, which is not too far, but it's about 1,200 Ks from the city of Darwin. Darwin would be the major city to here. This is a dirt road drive. It takes you about 18 hours to drive there. You got to ford 2 major rivers and so forth. Now, just because you're in the middle of nowhere, we have an Australian building code doesn't mean that you forget, because around this store, all the roads in the little community are all bitumen, and in front of the store, we poured a concrete slab. So I made sure that we had a disability sit down, pick up parking space, that we had a ramp to push the wheelchair, at the right gradient and so forth and so on. I insisted that they follow the building code. A lot of these builders, whether it be in Australia, Africa, Central America, or wherever it is, these people are just there to make money. They're going to cut the code. They're going to do everything. Now, sometimes we can appreciate it's never going to happen. It can't happen. There's no money for that. But still keep all those things in mind and do the best job you can to deliver the best product for the people. Okay. I built about 30,000 homes in Africa with compressed earth blocks. I had a building business for myself for 25 years. I built nothing but rammed earth. That was my real specialty. I built here in Australia. The only people that can afford rammed earth in Australia are people with money, high-end market. So my homes were very expensive. What I discovered working in Africa is, and I was always against these compressed earth blocks, but I think they're a good medium. Now, this particular machine here, it's called a hydroform. It was developed in South Africa. I was involved with that. I built about 30,000 homes in Africa with this particular machine. It takes a while, obviously, to understand soils and how to put it together. And this is a project that I was running here in Australia. The machine mixes the material. Someone puts it in a bucket. He puts it in that black little hopper you see sitting there. And then that arm comes down, compresses the block, and then it ejects the block sitting there on top. Those blocks have a male and female joint, top and bottom, and each end, so they interlock. You do not need to use mortar. And unless you're in a cyclone area, you don't need to tie them down as well. They're not going to go anywhere. So anybody can lay these blocks, 10, 12-year-old child, women, men, anybody. As long as you got some kind of a level footing, away you go. They're very easy. So I've run a lot of these type training programs, and that's just a picture of one of them. Here's a wall built. You can see it's quite a long wall. That's a wall that we built with these blocks. These blocks were made from material on site, stabilized. The MPa rating on these blocks, from memory, was somewhere around 12 MPa. So very, very structurally sound. Now you can see how I left the gaps in there. What I did is we put some shutters against those gaps. We pumped those with concrete, and then we poured a concrete bond right on the top of them, 200 mil thick. Those blocks are 220 mil wide. We put a piece of white 12 bar in that bond beam around the top, and it tied them all together. That was put down there, I don't know, 15 years ago or so. It's still there today. It'll be there for several hundred years. Here's one of the guys. This is a real trade secret. It took me about 30 years to figure this out. So I'm about to give you this secret. If you ever look at earth building, one of the things that you do in soil testing is you look at the maximum density and your moisture and maximum density on your material, so that you know how much it's going to compact, the weight, so forth and so on. And in that test that you do in your laboratory as an engineer, or at your geotech engineer that does it for you, they tell you that the optimum moisture content on that material is 10%. So when you're out in the middle of nowhere, how do you know what 10% moisture content on your soil is? Well, you don't. And you see all types of people picking up soil and putting their fingers and putting in balls and dropping on the ground, do all that stuff. That's all home builder, Mickey Mouse stuff that isn't very professional. All you have to do is get a little kitchen scale, like you weigh meat and whatever on. You know what's the moisture. So you take some soil, you put it into a cup, like one of those thermal cups that you can drain it. You put some soil, so you mix your soil up, you got some moisture in it. You put it in this cup, you put it up, you tar the cup on your scale, put the soil in there, you weigh it, you put it in there till you get to 100 grams, pop it in your microwave for 3 minutes on maximum heat. You pull it out, you put it back on the scale. There's how much it'll tell you. It'll tell you how much does it weigh. It weighs 89, 88, it weighs 80, whatever. It tells you how much. The difference in that obviously is your moisture content of that soil. So you can do that in the middle of nowhere and get perfect. So when you, as the engineer, sign off on this project, you know in your mind you've done everything that's humanly possible not to have a structural failure. And again, I can't emphasize that enough for you. That is your job and your responsibility, and you must deliver that. So that's what I'm teaching this young fella here. He doesn't really read and write very well, but he can figure out the math, and that's what he's doing. Here's me with the fellas with a few different soils, and these blocks have been made to send back to the laboratory in Darwin for testing. Here we got the blocks, and we've got them on a piece of hessium, and we're drying them for 1 hour, and we're capping them, as you can see, and then we're putting them and compressive testing them to see. We've already done that with our samples, but now we know that the blocks we're manufacturing actually work. And what happens is that I make the people on site send blocks. I ring them on the phone if I can't be there in person and say, send 10 blocks to Darwin via freight, and then they cap them and test them, and we make sure. And every day they scratch onto the block what day they manufactured it, so I can ring them and say, look, on the 23rd of September, the blocks didn't come, they were 6 MPa, not 10. You know, crush them back and do them again. This is what the inside of a school looks like that I worked on, and these are the same blocks. You can see that they cost about 10 cents each to manufacture. Here's a clinic that was built. You can see I didn't get away from concrete. I like to tie a concrete bomb beam in there, so that's where your engineering comes in. But these blocks, you can make them all day long. You can put them in there. They cost you nothing, and so forth and so on. I did this job about last year, I think it was, in South Africa. One of the engineers I trained in Durban, South Africa, who's now about 45 or 50, was looking at this project, and he rang me up and said, I want to do this compressed earth block project. Now you can see these blocks are just, straight. There's no interlocking on these things. So they're laying them like blocks. He said, I want to do this with these earth blocks. Will you help me? So right here from my desk, I directed him through this whole project, all the testing, and so forth and so on. I am at this very moment working with an engineer from Nigeria. This is my second project in Nigeria. I spent a bit of time in Nigeria, very dangerous place, but I spent a bit of time there. This is my second project, and I'm doing a rammed earth project. I've taken him step by step. Okay, you take the soil, get this test done. He comes back to me. I say, right, next step, we do this, do whatever. We'll get through that. We'll build the whole thing. I'll show him how to do the footings. I'll do the drawings for him, whatever. And he's done. So this is one of those kind of projects in South Africa. Here's a picture I wanted to show you because, as you can appreciate now, these particular blocks we're laying a mortar joint. And so a string line in South Africa, a string line to me and a string line to all of you when we're building a project, and we got a profile at each end, and we pull the string line, the block layers pull the string line, and he's laying these blocks of that string line, and that string line's keeping those things in a horizontal plane, and he's got a level that he's also keeping them level on the top. He's checking them to be vertical. He's doing all that. Well, they most likely don't have a level, and string line in South Africa lots of time is fishing line. And you put a fishing line taut, as you would know, and then it becomes 40, 45 degrees outside, that fishing line sagging and blowing in the wind, and the walls are going like that. So what I did is I had them screw off these steel, and then those yellow steel timbers there, put them there. They're all vertical, and they just lay the blocks to those so that I know that at least the thing is vertical. Horizontal, well, I mean, across the top, yeah, maybe. I might be in and out a little bit, but they got to finish at the top of those yellow planks, and they work that, and it works out a treat. So anyway, they finished that job. You can see the building. This is another picture. This is another building. It was quite a series of buildings. Here's another one. And this is the entrance to the building as you walk in. So again, we used earth, but we also had some concrete. We got some bottles, just some beer bottles there, as you can see in the entranceway. I should say, I want to apologize for you because I've been traveling in remote Australia. I didn't really put a lot of pictures together, didn't make it into a PowerPoint. So please forgive me for doing that. I've had plenty of time. I just haven't had time to do that. I also have a foundation that keeps me busy, so I'm always recruiting from corporate to buy things for people in remote Australia. I'm also lecturing at the university. I'm also running a consultancy business, and obviously I have a huge family as well. So I do my best. I want to finish by saying, thank you for listening to me. I hope I haven't been too boring. I'm planning on coming to Prague in 21 for the conference. So I hope to see some of you at the conference. I'm on the scientific committee again. This will be our 6th. And I'm back to you.